Hello and welcome back to Business Statistics. So today we're reviewing Chapter 11, which is all about analysis of variance, also known as Anova. So Anova testing allows you to compare two means. Basically, it's trying to explain the variation around the mean, which is the explained variation plus the random error. Now, for the Anova test, we use the F distribution, where variance 1 squared is divided by the variance 2 squared. And there is a useful YouTube video on this called Innova Playlist Statistics Fun, and it is by Statistics Fun, which I would suggest you watching it when you do your homework. It will help you explain this in more detail. Now, some of the Anova assumptions to keep in mind are that the Y observations are independent, the sample population is normal and have equal variances, and the one-factor Anova as a linear model has a formula of Y equals the common mean mu plus the treatment A plus the error E. So there is a useful YouTube on this called Partitioning, the Sums of Squares in Anova, and that's by Professor Paris that you might want to check out on YouTube. And it might help you explain in more detail while you're going through the homework assignments for this chapter. Now there's also Tukey's test in this chapter that we for when we reject a hypothesis and we want to run an honestly significant difference, also known as Tukey's. So there's as well a YouTube video on Tukey's test in Excel by Terry that you might want to check out as well if you're doing homework assignments involving Tukey's test. And for equal variances in C treatment groups, we use what's called Hartley's F-max test. Now, this one, there is a YouTube as well that explains it in more details, and it's called How to Run a Test for Equal and Unequal Variances F-Test in Excel 2013 by Eugene O'Loughlin. So again, I would suggest looking at these videos to get more detail of each of these formulas when you're doing your homework assignment. Now, let me review in Excel Anova single factor testing. I think it will be useful to you when doing your homework. Let me do that now. Now, looking at Anova testing, we are going to be using, similar to what we used in previous chapters, the Excel minor analysis tool pack. Now, in the way you get to this is you go to your Insert tab, and there should be add-ins already in there because you probably already looked at this in while doing other hypothesis testing. But if you still don't have those add-ins in there, you go to File, go to the bottom where it says Options, then look at the option that says Add-ins and click on that, and then it should give you an Analysis Tool Pack option here that you press OK on, and then basically you are able to get an add-in toolbox that looks like this. So the Excel Minor Analysis Tool Pack box. So in this case, we are looking at similar to how we did in other examples, the old bulb performance versus the new bulb performance. And we're going to run an Anova test on this as well. So in this case, when we go to the Excel Minor Toolbox, we are going to pick the Innova single factor test. So we just basically click on that, which is at the very top of this box. And then we do similar to how we did other hypothesis testing. We're going to go ahead and do the input range similar to how we did it before. So in this case, we are picking both columns. So what we're going to select for the input range is going to be all the way from B2 here, all the way down to C16 here. And that's going to be our input range for this Anova single factor box. The data is grouped by columns, so we are going to pick columns. In this case, I did not choose the labels when I picked my data in the input range, so I'm not going to check the labels box. And my alpha, it's already set at 0.05, and I'm going to leave that way. Finally, my output range, I'm going to go ahead and do it on cell M2. That's basically to display the data for the Anova single factor results. And then you just press OK. And what's going to come up is this data box of information for Anova single factor results. So the summary is basically going to tell us what our information we provided is. So the count, so there were 15 items in each column, their sum, the average, and the variance. And then what we want to focus on is on the information at the bottom of the Anova box. That's going to give us the source of variations between groups. So in this case, we want to look at the p-value, which is significantly lower than our f-critical value. But our f-critical value is set at 4.196, and that's the answer that we're looking for, versus our f-value, which is at 5.947. So this is how you calculate an Anova single factor test on the data that we were provided here in columns B and C. And hopefully this is helpful when you're doing your homework exercises for this chapter. We'll do some more hypothesis testing on the next chapter. Hope you have a good one. Bye-bye.